Hi students, in this session let us solve this gate question which is from signals and systems. So here the system is discrete time system, input is x of n and output is y of n. So the system is enclosed in a dashed box which consisting of two subsystems, subsystem 1 and subsystem 2, h1 of n and h2 of n respectively. Now here you have to determine whether this system is linear or non-linear or time variant or time invariant. So now let us assume that the output from the summer is A of n and output from this subsystem 2 is C of n. Okay, now you have to write the respective equations. So what is A of n? A of n is nothing but convolution of x of n with h1 of n plus b del of n. Okay, so here A of n is the input to subsystem 2 and C of n is the output to subsystem 2. Now what is C of n? C of n is nothing but convolution of A of n with h2 of n. Okay, so already we know what is A of n. A of n is x of n convolution of h1 of n plus b del of n, which is convolved with h2 of n. Let us simplify this. So which is nothing but x of n convolved with h1 of n convolved with h2 of n plus b del of n convolved with h2 of n. Okay, so the first term is as it is, but the second term is simplified. Let us go to write this first term as it is, h2 of n plus here b as it is. Here the del, an impulse function, is convolved with the h2 of n. We know that if an impulse function is convolved with any function, then gives that the same function. It means h2 of n. Okay, so this is output of subsystem 2. Now we have to determine the output of the respective system, which is y of n. Y of n is nothing but C of n minus b del of n. C of n, C of n, b minus b del of n. Okay, let us write this. X of n convolution of h1 of n convolution of h2 of n, okay, plus b h2 of n minus b del of n. Okay, now see here. So the first term which having the input term and there is no input in second term. So let us assume this as z of n. Now I am rewriting this y of n as x of n convolved with h1 of n convolved with h2 of n, okay, plus z of n. So here the z of n is, this z of n is independent on input signal, which is x of n. Okay, so now you have to check whether the y of n is linear or non-linear, time variant or time invariant. So first check the linearity. So coming to linearity, if there is no input, if there is no input means x of n equals to 0. It means that if if the system satisfies the linearity, then y of n output should be equal to 0. But in this case, output is not equals to 0. Why? Because so it equal to y of n is equal to z of n. Even there is no input, there exists the existence of output, so which is nothing but z of n. So that is the reason the system is not linear. It means it is non-linear. Okay. Next, coming to time variant or time invariant. So according to time invariance, okay, so if the input is shifted to, k, then the output is also, output y of n is also shifted by k. Okay, so here the first term that is x of n convolution of h1 of n convolution of h2 of n. So this term obeys this time invariance, but even the shift in x of n, there is no change in z of n. Okay, even the shift in the input x of n, there is no shift or no change in the z of n. Okay, so that is the reason the system is not time invariant. So not time invariant means the system is time variant. Okay, so that the answer is the system is non-linear and time variant. Non-linear and time variant, so answer D. Okay, so if you like this, please like, share and subscribe. Thank you.